Welcome! Today, we're diving into an essential topic and statistic, confidence interval for proportion. Whether you're studying statistics or working with data, understanding this concept is key to making accurate and informed conclusion. Let's start with the basics. A proportion is simply a part of a whole. For example, if 30 out of 50 students pass a test, the proportion is 30 divided by 50. That's 60%. But what if we want to estimate how many would pass in the entire school, not just our example? That's why confidence intervals comes in. We use them to estimate the true proportion in a population based on a sample. A 95% confidence interval means we're 95% confident that the true value lies somewhere in that range.
In this portion, we will walk through the formula for confidence interval for proportion, a simple method used to estimate the proportion, especially when working with small samples. So, these are the formula for solving the confidence interval for proportion. The first step is adjust the sample size. We start with our original sample size n and add 4 to it. This new value called n tilde or adjusted n help us to stabilize the estimate, especially for small data sets. And second step is to adjust the number of successes. Here, x is the number of observed successes. We add 2 to it and divide by the n tilde to get p tilde or the adjusted proportion of success. So the third step is plug these adjusted values into your confidence interval formula. So this is the formula where the z alpha divided by 2 is the z-score for your desired confidence level for 90%. It's about 1.645. The square root term is the standard error for p tilde. Then we multiply them to get the margin of error and add and subtract it from the p tilde to get the interval. Last step is to check the limits. If your lower limit is below 0, set it to 0. And if your upper limit is greater than 1, set it into 1. This ensures the confidence interval stays within the valid probability bands. Let's take a quick recap. Let's summarize the steps in solving the confidence interval for proportion. The first step is to add 4 to your sample size. Second is add 2 to your number of successes. And third is use those in the plus 4 formula. And last step is adjust limit to stay between 0 and 1. This simple tweak improves the accuracy of your interval, especially for small sample size. That's the power of the plus 4 confidence interval.
Now that I have already introduced you the formula on solving the confidence interval for proportion, let's proceed to these example problems.
Let's proceed to the problem. Here is the problem. Example 5.12. Interpolation method are used to estimate heights above the sea level for location where direct measurement are unavailable. In the article, transformation of ellipsoid height to local leveling heights, a weighted average method of interpolation for estimating heights from GPS measurement is evaluated. The method made large errors whose magnitude was above the commonly accepted threshold. At 26 of the 74 sample test location, find the 90% confidence interval for the proportion of location at which this method will make large errors. Based on the problem, the given r, n, or the sample size equals to 74. And x, or the number of large error, is equals to 26. And lastly, the confidence level is equals to 90% or 0.90. Now we solve. First, we get the adjusted sample size where we add 4 to the original sample size. 74 plus 4 is equals to 78. Second is we get the adjusted proportion where we add 2 to the number of large error, or the 26 plus 2, and then we divided it by 78, or the adjusted sample size, is equals to 0.3590. Now we will substitute these values in this formula. Square root of p multiplied by 1 minus p divided by n is equals to square root of 0.3590 times 1 minus 0.3590 divided by 78. We get, use your calculator, 0.0543. Next, we get the alpha. We all know that confidence interval or confidence level is equals to 1 minus alpha. Transpose the formula, we get alpha is equals to 1 minus confidence level. Alpha is equals to 1 minus 0.90, or the confidence level that is given. Alpha is equals to 0.10. Now we get the z alpha divided by 2. Z alpha divided by 2 is equals to 0.10 divided by 2. We get G alpha divided by 2 is equals to 0.05. Later on, we will use these values. Since we get all the values that we will use in the confidence interval formula, now let us substitute it. So the formula for confidence interval for proportion is p tilde plus minus z alpha divided by 2 multiplied by the square root of p tilde multiplied by 1 minus p tilde divided by n tilde is equals to, the p tilde is equals to 0.3590 plus minus the z alpha that we get 1.645 multiplied by 0.0543. This can be rewritten into 0.270 or 0.448. That's all. That's the answer. This is the solution in the textbook. As you can see, we come up with the same answer. Now let's proceed with the second example. Example 5.13. In example 5.12, what sample size is needed to obtain a 95% confidence interval with plus minus 0.08? In this problem, we will find the sample size. The sample size is the unknown. So the given that we'll be using is first the confidence interval that's equals to 95% or 0.95. In the Z table or the standard normal distribution, it is equals to 1.96. The second given is the p-tilde or the adjusted proportion that is already given in example 5.12. So it is equals to 0.3590 and the unknown is the n or the sample. Now we will substitute the given in the formula. So this is the formula. Solution 1.96 multiplied by the square root of p-tilde multiplied by 1 minus p-tilde divided by n-tilde, but the n-tilde is unknown, where the n-tilde is n-tilde is equals to n plus 4, the adjusted sample, and p-tilde is already given, is equals to 0.3590, and the width is equals to 0.08. Now substitute the given in the formula and use Caltech since n is unknown. So we come up with the answer of 1.34.1289 or n is approximately 1.35. In the textbook, it is 1.35. As you can see here in the calculator, I use Caltech. And the answer is, this is the answer and solution in the textbook. Lastly, let's hop into the traditional method. The traditional method for confidence interval uses the sample proportion and size without adjustment. It works well only when both successes and failure are over 10. But even with larger samples, it can be too optimistic, meaning the true proportion might fall outside the interval more often than expected. That's why a newer method like the +4, like kanina, is often preferred. It slightly adjusts the sample size and number of successes to give more accurate and reliable interval, especially for small to medium samples. For large samples, both methods give similar results. This is the traditional method. So that will be all. I hope you learned some things. Thank you and God bless.